Alright, here's the problem we looked at in class related to a new sports bike. So the theory is design a bike and I just have to figure out how many to make and what I should charge for the bikes. So we've done some market research, and so these are some things that I know. I know that there's a fixed cost of $700,000 just to get set up. And for every bike that I make, it's going to cost me $110. That would presumably be for parts and labor. Here's some other information. We've done some research and established that depending on the price, we're going to lose 200 bike sales from an initial 70,000 bikes. In other words, we can give away 70,000 bikes. That's how many we're able to make. But we would lose 200 bike sales for every dollar increase in price. So that's a linear function. That's established right here. So what we can do is establish that if we charge $100, we would sell 50,000 bikes. If we charge $200, we would sell 30,000 bikes. And the somewhere around here looks like 340, 350. If we charge that much for the bikes, we're not going to sell any because nobody's going to pay that much for the bike. So this is a little oversimplified, but essentially it's a linear function to describe the demand based on the price. So the price is going to tell me how many bikes I'm going to sell. The number of bikes I sell is going to accumulate my total costs, and the number of bikes I sell is going to tell me about my revenue, which is how much money I actually make. So just to try to understand how all these variables are related to one another, I started with a fixed price of $100. And according to my demand curve, $100 times 200 bikes lost per dollar gives me a total loss of 20,000 bikes from my initial 70,000 bikes, which means I will sell 50,000 bikes if I charge $100 for them. Now, if I sell 50,000 bikes at $100 per bike, that's going to give me a total of $5 million in revenue. Sounds good, until you recognize that your costs are going to be accumulated as $700,000 in fixed costs, plus, remember we sold 50,000 bikes, but we have to pay $110 for each of those bikes. So we have to pay $5.5 million plus an additional $700,000, or a total of $6.2 million just to produce those bikes. So, to figure out our profits, we would have taken in $5 million, we would have been charged $6.2 million, so a profit of negative $1.2 million, or in other words, we lose $1.2 million if we make and sell 50,000 bikes at $100 a piece. Not a good scenario. Nonetheless, I decided to see what happens if I sell the bikes for $200. $200 means that I would take 70,000 bikes and I would lose 200 bike sales for every dollar. There are 200 total dollars, so I lose 40,000 bike sales for a total of 30,000 bikes sold. If that's the case, I would sell 30,000 bikes at a cost of $200 per bike for a total revenue of $6 million. On the flip side, I would have $700,000 fixed cost plus $110 times 30,000 bikes sold or made, and that gives me $3.3 million in cost plus the additional $700,000 fixed cost, or $4 million total cost. Quick calculation shows me my profits would be $6 million revenue less $4 million cost, for a total net profit of $2 million for bike sales. Now, if you recognize the relationship between what I just did here and what I did with a $100 price, it's all the same mathematics. So if I can generalize now, I can say that if the price were P dollars, then I would sell this number of bikes. That's 70,000 minus 200 P. So this is a number, and it represents the total number of bikes sold. Revenue will be the selling price times the number of sales. So the price times the number of sales, and the number of sales was given by 70,000 minus 200 P, and the selling price was given by P, and so this expression right here is a formula that will tell me my total revenue no matter what I set my price at. So for example, $0 means zero revenue. If I make it $200, I could put 200 here, multiply by 70,000, take 200 here, square it, multiply by 200, subtract, and that'll be my total revenue. Cost can be figured out in much the same way. We have 700,000 plus $110 times the number of bikes sold. And remember, up here we established the number of bikes sold depends on the price. So I take the number of bikes sold, put it in for the price, put that in for the number of bikes sold, and distribute the 110 and collect like terms. And so this is a simplified expression representing the total cost. If I know what P is, the price, I multiply it by 22,000, subtract that from 8.4 million, and that will give me my total cost. Similarly, we can figure out our profit by taking our revenue and subtracting a cost. So here's my revenue expression. I put that here in parentheses. Here's my cost expression. I put that here in parentheses. And the rest is Algebra 1. I distribute the negative, so that's here, and collect like terms and rearrange it in quadratic form. And so this is my profit equation. It's a lot of zeros. It's kind of a clunky equation, but it's quadratic, which means I could do quadratic stuff to it. So first of all, I want to make sure that this is a valid equation. So I remembered when I set the price at $100, I had a negative $1.2 million profit. So just to check, I'm going to substitute 100 in for price in my equation and see if it totals out to be negative 1.2 million, and indeed it does. So my specializing was great because it gave me a self-checking mechanism to make sure I did my algebra correctly. So this is the right profit equation. Now to maximize the profit, I simply have to figure out what the price would be, and the maximum price exists at the axis of symmetry, opposite of B over 2A, which reduces to $230. So I noticed a $2 million profit when I charged $200 per bike. If I charge $230 per bike, I'm actually going to get a profit of $2.18 million. So it's an extra $180,000 in profits by raising the price just another $30 more. I did get this from using the graphing calculator, incidentally. As a matter of fact, I'll get to the graph first. I presented all of my findings in graphical form. Here we have bikes sold, and we have millions of profit, and we have my maximum profit for the price. I have two different prices that will allow me to break even. Here's one of the checkpoints that I did. That's 100, negative 1.2 million. And so this represents my profits as a function of price. And I should change that. That's actually price there, isn't it? There. All right. All of the work that I did, I supported with the technology. So I entered the equation that I found, and I have the graph after I set up a viewing window. Luckily, I knew that I had to go to $550 because I basically doubled my maximum profitability, so I can see the parabola at both sides. Negative 2.5 million up to 2.5 million, and there's my scale. So there's the graph, and we could do things like calculate value and check when x is 100. We are at negative 1.2 million. That's consistent. We have when x was 200 that our profit was 2 million. That is consistent. And 230, and our profit is 218 million. So all the stuff that we found on pencil and paper is verified by the calculator. Moreover, I could use this calculator to find the maximum. I could use the calculator to find where my x-intercepts are. I could do all that stuff. So supporting my work with technology and transferring what I see in the technology onto paper so that everybody can see what I saw. Thank you.